In this lesson, we're going to take a deeper look at period and amplitude in relationship to sine and cosine functions. Okay. So the first thing I'm going to do is just copy over some of the definitions that we got from the last video. So if we recall, the amplitude is the vertical distance. It's the vertical distance from the midline. So it starts at the midline to either the maxima or a minima. Okay. And then another thing we remember is that it's always positive. Okay, so it's always positive. The way we would find this is we would take the absolute value of A, and that's our amplitude. The period, on the other hand, this is going to be the length of one cycle. Okay, so I'm just copying it down from over there. This is also always positive. Okay, so always positive. And then we would calculate this by doing 2 pi divided by b and then the absolute value of that. Okay. And then the last thing that we'll look at this probably a little bit less like on Canvas, but the frequency is the number of cycles. So this is the number of cycles a graph does or it completes within an interval of 2 pi. So if we started at 0 and then went to 2 pi, that would essentially be the absolute value of b. Okay. So what are all these letters A and B about? Okay. Now we'll take a look at that a little more closely today. So yesterday we learned about the parent functions, and now we're going to add the letters A and B. Okay. So A is going to represent the vertical stretch or compression, while B represents the horizontal stretch or compression. So you can actually, it's really cool, experiment with these a little bit in Desmos. So let's say we go to Desmos right now, and we'll just take a look at the sine function to start. So if I put A, so if I put a number in for A, let's say I put in the number 3, what happens? Okay. So A is going to correspond to the vertical stretch, so I can make this number bigger, and it's just going to continue to stretch this function more and more and more as high as I want it to go. Notice that that's the value, that the highest point that it goes to on the range, okay? And similarly, it's stretched down to that negative value on the range as well, okay? What happens if I put a negative number? Okay, let's say I put a negative number in for A. What do you think is going to happen? Okay, so if you just caught that, what happened is all of the hills, like if I put 3 sine of x, which is the positive one, all of these hills in the positive one turned into valleys. Okay, they flip-flopped, everything flip-flopped around. And that makes sense, because if we put a negative in front of something like x squared, so let's say we have just simple old x squared, if we put a negative in front, everything flips around upside down. Okay, so we've learned that before when we've looked at functions. Same thing happens for sine and cosine functions as well. When we put a negative in front of them, it just flips them upside down. Similarly, we could put fractions in front of the sine function. What happens if we put fractions in front of it? Well, let's see. Let's put the fraction 1/2 in front. Okay, so it looks like it got compressed. It got squashed down a little bit. And the smaller the fraction we put, the more and more squashed down it becomes. Like if we put in a really tiny fraction, like 1/1000, it almost looks like a straight line here, like it just flatlines completely. It becomes so compressed. Okay. Same thing happens with cosine if we were to dive a little bit closer into cosine as well and add an A and B to them. Okay. So the first couple problems that we'll look at, we're going to look at a function where they have a value for a and a value for b inputted into it, and then we're going to have to find the period, amplitude, and frequency for each function. Okay? So this particular function, what would the period be? Okay, so if I look here, the period is calculated by doing 2 pi divided by b and then the absolute value of that. Okay, so remember b goes right here. That goes in parentheses with your x value that you have. Notice there's a second set of parentheses. In the next lesson, we'll look at putting something else with the x inside of the second set of parentheses. But for right now, if you just have that number times x and that's in parentheses, that works too. Okay? But in the future, we'll be putting something else in the second set of parentheses. So the way they have it written right now, where it's just b times x, that works just fine. Okay? So if I do 2 pi divided by 3, and then the absolute value of that, which just makes it positive, that is my period for the function. Okay? And then the amplitude, that is just going to be the absolute value of a. So whatever number is right in the front, which is 3, that is my amplitude. And then finally, the frequency is the absolute value of that b, so it is also 3 as well. Okay? All right, let's look at the next problem. So the period for this one is 2 pi divided by, and then this would be b, 1/4, okay? So 2 pi divided by 1/4, and the absolute value of that, so it just stays positive. So recall that if we have, if we're dividing by a fraction, we can take the reciprocal and flip this around and multiply it. So I'm going to have 2 pi multiplied by, and I take the reciprocal, so I flip this around and multiply it. Multiplied by 4/1, which is just 4. So this is going to give me 8, because I just take 2 and 4 and multiply that, so 8 pi. And the 1 doesn't matter, because remember, this is just multiplying it by 4. Okay? So 8 pi is my period for this. Amplitude is the absolute value of that a, so the absolute value would be 4, positive 4. Well, the frequency would be 1/4. All right, so that's pretty easy if we see everything written out for us in terms of the function just being written there. But let's say we're given a graph instead. How do we find the period, amplitude, and frequency if we're looking at a picture? Okay. So this is where it becomes a little bit trickier. So if we remember the definition of period, period is the length of one cycle, okay, the length of one cycle. So if I started here, okay, one cycle around the unit circle would end right there, okay? So that would be the length of one cycle. So what's this value right here? Well, if this is pi over 4, this is 2 pi over 4, 3 pi over 4, 4 pi over 4. I'm just counting by the fractions that I see there, okay? So we can think of this as like 1/4, if we imagine that the pi goes away. 1/4, 2/4, 3/4, 4/4. Well, what does 4/4 simplify to? That just simplifies to 1. So this would just be 1 pi, okay? So that distance of my one cycle is the length of pi, okay? And this would also simplify as well, like this would simplify to 1/2, or in other words, pi over 2. And the 1 is there, but it's invisible, so pi over 2. So hopefully that helps you a little bit when you're looking at these fractions. So this period would be a length of pi. What's the amplitude then? So that's the distance, the vertical distance from the midline to either a maxima or a minima. So there's the midline right there. This would be a maxima or a minima. So what is this vertical distance here? That would be my amplitude. So that looks like it is a distance of 1, okay? So my amplitude is 1. And then my frequency, this is the number of cycles a graph does in the interval of 2 pi. So from 0, if I start at 0, and then I end at 2 pi, well, this is pi right here. Where would 2 pi be? Okay, it would be definitely past this a little bit. So let's think about it this way. So from 0 to pi, it goes through one cycle. It does one cycle, okay? How many cycles would it go through in 2 pi? It would go through 2 cycles, okay, by the time it got to 2 pi. So our frequency would end up being 2 pi. All right. Let's try another example of this, because I know going from the graphs and figuring out all of those key features can probably be the trickiest part of doing period, especially. Amplitude is not too bad, but period can be a little bit weird sometimes. So take a second and see if you can match this up correctly, and then we'll go over the answers right now. So the first thing I would remember if we're looking at this is the general shape of sine and cosine, okay? So if I have a sine function, I remember that the shape of it from the last video looks like this, okay? So that's the parent function. It starts at the origin, goes up right there, it hits the midline, comes back to a minima, and then comes back to the x-axis again. Where cosine, the shape for this is that it starts at whatever its maxima is, goes down, hits the x-axis, goes to its minima, then it goes back to the x-axis, and then back up to a maximum, okay? So there's sine and cosine. So knowing those shapes, I can kind of figure out which of these are sine or cosine functions, okay? So it looks like anything that's going to go through the origin right now would be a sine function. So I'm betting that this is a sine function as well as this, okay? Where this would definitely be a cosine function. How about this one down here? Well, if you recall when we were talking about negatives, okay? Negatives are where all of our maximas become minimas. Everything flips around and the minimas become maximas. So this looks like, to me, this looks like a negative cosine function because typically it starts up here, but now it got flipped around the other way. So where it's starting here, and then this is the maxima and this is the minima. Okay, all the hills and valleys flip-flopped. Okay, so right away I can tell that this is the negative cosine function, so this is C. Okay, and then all of the rest of these have an amplitude of 4. They all start at 4. That's their amplitude. That's the highest that they go up, okay? So we can't really distinguish them from there. But then we also know that our leftover cosine function is probably going to be this one. We definitely know that this is cosine. So now we're just figuring out the sine functions, which one is which. And the only way to distinguish those are by the b that we're given. So this one has a b of 1/4, this one has a b of 4, okay? So let's say we were to look at the period for both of these, okay? So if we started here, and if we went one cycle around the unit circle, so go up, here, go down, there, okay? That goes through one of these shapes, okay? This would be one cycle. So if I went through one cycle, what is the length of that? What is that period, okay? So again, think of this as 1/4. If this is 1/4, and that's halfway in between, this would be 1/2, okay, or pi over 2, 1/2. So this would be the period here. It's pi over 2. How about the next one? What's the period for this? So if this one starts here, and we're following this general pattern, when does it go through one hump, come down, and then land back on the x-axis again? So go up, down, lands here, that's one cycle, okay? So what is the length of that? Well, this one, if I go one tick, that's 2 pi. Second tick would be 4 pi, because that's another 2 pi. Another 2 pi would be 6 pi, and then I have 8 pi, okay? So there's definitely a big difference in the period here. This one has a period of pi over 2. That's the length of the cycle. Well, this one has a length of 8 pi. Okay. So here's what we'll do. We can pretty easily look at our function and then find the period, because we just know that it's 2 pi divided by b. So let's say I do 2 pi divided by b, which is 1/4. What does that give me? Well, a second ago we actually just calculated that. So 2 pi divided by 1/4, that gives me 8 pi. Well, if I did it for the other one, 2 pi divided by 4, 2 pi divided by b, this simplifies down to pi over 2, or 2/4 simplifies to 1/2. So now I can clearly see that this one matches up to b right here, well, this one matches up to d. All right, the last couple problems that we'll take a look at, this is where we're going to be given an amplitude and a period, and we actually have to create our own function given those two things, okay? So a cosine function given the amplitude and the period. So I know we have cosine here. If the amplitude is 7, where does that go? Okay, if I have my cosine function here. Well, the amplitude, that number, goes directly in front of our function. Okay, amplitude goes at the very front, so that's 7. And then b, if we remember, we have a here, and then we have b times x inside of it, okay? B would go here. Be careful that you're not taking the period and just plugging it right in there. So I would not just write pi and then call it a day, okay? Because the period is different than b. So what I'm going to do is I'll take my period and then use it to solve for b, okay? So I know that for the period, in order to get the period, it is equal to 2 pi divided by b, okay? Right now I have the value for the period. I know the period is pi, so I'm going to plug that in right here. So pi is equal to 2 pi divided by b, and then now I have something that I can solve for b. So I can easily cross multiply this, and I get b times pi equals 2 pi. Divide both sides by pi to isolate b. So that cancels out, and this cancels out as well, so it looks like b is a value of 2, okay? So that's what I would plug in here. And there's my function if the amplitude is 7 and the period is pi. Okay, let's try this one more time. So let's say I have another cosine function. The amplitude here is 1, so I don't even need to write that 1. It's a little unnecessary. But if I'm solving for the b that goes here, the b value, I know that my equation is period is equal to 2 pi divided by a b. So since I know the period is pi over 6, I plug that in for the period. And then I can cross multiply to solve for b. So I get b times pi equals 12 pi, okay? Divide both sides by pi to isolate b to get b by itself. And I see that b is a value of 12, okay? So that would be my function. One last time. Cosine there. The amplitude is 1/2, so I can put that at the very front. And then using this formula that we have for the last two problems, I know that period is equal to 2 pi divided by b. Okay, so if my period is 7 pi, I can put a 1 underneath the 7 pi, so I can use that to cross multiply. So I get 2 pi equals 7 pi times b. If I divide both sides by 7 pi, that cancels. The pi's cancel. I get 2/7 for my b. So this is 2/7 there.